Hey, welcome to this lesson. We're going to be talking about how to solve linear equations. You'll see this as a standard in your grade book titled Linear Equations, solve, because there's a lot of aspects to linear equations, but in this case, we're going to be looking at how to solve a single equation with a single variable. We're starting off pretty basic here with x plus 5 equals 12, and if you'll notice my notes here on the left-hand side, it says there are three main methods for solving equations: rewriting, undoing, and looking inside. Now, most of those methods we're actually going to get to in Chapter 10 when we look at ways of solving. However, we're going to be looking mainly at rewriting and undoing in this case here. And my 4 steps that I have below, if you struggle with solving equations, although you can do things in any order you want, as long as you maintain the golden rule, whatever you do to one side, you must always do to the other. However, these 4 steps seem to work most of the time, the majority of the time. And so if you are struggling and you're like, I just need a step-by-step process, use these 4 steps and you can get there. First thing I want you to do, whenever you solve, put a line down the center of the equal sign. That makes sure that we keep things balanced. Whatever I do on the left side of that line, I will do on the right side of that line. I've seen students do the same thing on the same side of the equation twice, and that was a mistake. You want to do it once on the left side and once on the right side of the equal sign, and so that's where the line helps us. All equal signs should then be put on that line. First thing I'm going to do is get x alone. All right, I want all my x's on the left side. That's done. It's simplified. I want to get x alone, though. So what's with x that it doesn't belong? That 5 right there. I want to get rid of that 5. How do I get rid of a 5? Well, I always undo. I do the opposite. All right, this is a plus 5. The opposite of plus 5 is subtract 5 from each side. So I'm going to subtract 5 from each side. X equals 7 in this case. Pretty straightforward there. How do I know that that is correct? Well, I want to plug that back into my equation. I can substitute the 7 in for x, add 5 to it, and I want to check, does that indeed equal 12 as it's supposed to? Well, 7 plus 5 is 12, and that equals 12, and therefore we are correct. 7 is the solution to this equation because 7 is the value of the variable that makes this equation true. That's what we can see here. A solution to an equation is the value of the variable that makes the equation true. All right, the truth is out there. That's what you're looking for. When we say solve, all right, you are looking for the solution, and the solution is whatever makes that situation true. In this case, we're looking at equations specifically. Let's check out another one. What if I get something like this? Now looking at x, it's not alone. I've got divide by 5, and in this case, what's the opposite of dividing by 5? Well, multiplication is the opposite of division, so multiplying by 5 would be the opposite of dividing by 5. Those would cancel each other out because they are opposites. We'll talk more about why in Chapter 5 when we look at the properties. All right, but in this case here, 7 times 5 is 35, and so I find that x is 35. Now, is that true? Does it make it work? Well, let's plug it back in. I'm going to substitute 35 back in for x and check, does it indeed give me 7? 35 divided by 5 is 7. 7 equals 7. 35 was the value of x that made the equation true. Again, the solution to an equation is the value of the variable that makes the equation true. Let's get a little bit more complicated now. Now, all of a sudden, we've got x's with a multiplication and a constant there with it. So I'm going to go to my steps here. First off, look to simplify both sides. There's nothing I can do because it doesn't have parentheses or like terms. Move all my x terms to one side. Well, all my x's are over here already. There's no x's on my right side of the equation. So I'm going to move down to my third step here. All right, move all the other terms to the other side. So the 2x is one term, the minus 7 is another, and I'm going to do the opposite, add 7. All right, now I've got my x term by itself, and on the other side, I've got 22. All right, now I'm going to isolate x by doing the opposite, divide or multiply. This is 2 times x. The opposite of multiplication is division, so I'm going to divide by 2. What I do to one side, I must do the other, giving me x equals 11. And again, is that my solution? Well, you can always check it. Use your calculator if you want to, but let's plug it back in, and we're going to check. All right, 2 times 11 is 22, minus 7 is 15, and 15 equals 15, and therefore 11 is the solution to this equation because 11 is the value of the variable that makes the equation true. All right, next one, get a little more complex. Now we've got x's on both sides. Draw my line down the middle. Still nothing to simplify. We're going to get to those examples in a little bit, but let's move all of our x terms to one side. I first like to move my smallest x. I have 1x and a negative 3x. I like to move my negative 3 by adding 3x to both sides. It's not wrong to subtract x. I just find that you might make more mistakes with negatives at that point. This gives me 4x plus 2 equals 7. And then I'm going to move all my non-x terms to the other side by subtracting 2 from each side. All right, giving me that 4x equals 5. Now, that is these two steps right here. Move all x's to one side, everything else to the other. Those can be done in either order. I like to move my x's first. It's not wrong to do it the other way, though. Isolate x. It's 4 times x. Opposite of multiplication is division. So I will divide by 4 on that side. What I do on one side, I must do on the other. I find x is equal to 5/4. In this case, it is a fraction. You could leave it as 5/4. You could also write it as 1 1/4. Or you could write it as 1.25. Any of those would be acceptable. I prefer this one or this one. I'm not a fan of mixed numbers as much because I don't find the use as valuable in algebra. All right, let's take a look. Now, is this my solution? Plugging it back in, you could do the decimal or the fraction there. I'm going to do 5/4 plus 2. Does it equal 7 minus 3 times 5/4? All right, and if you plug that into your calculator, you will see that you get, in this case here, you're going to get 3.25 equals 3.25, and that is true on both sides. Therefore, it is the solution because, again, a solution to an equation is the value of the variable that makes the equation true. Let's kick it up another notch. Now, all of a sudden, we have to start simplifying. In this first case here, I see simplify by distributing and combining like terms. Anytime you see parentheses, we can distribute to get rid of them. In Chapter 10, you'll learn a new way that you don't have to distribute. There is an alternate route you can take, but distributing is a good route. All right, and that's the one we're going to start off with here. So I'm going to distribute that 2 into both of those, giving me 6x plus 10 equals 34 minus 2x. Now let's get all of our x's to one side and everything else to the other. I'm going to do something here that's going to save me time. I'm going to do both of those steps at the exact same time. I notice I want to move this 2x by doing the opposite, so I'm going to add 2x. At the same time, I notice that that's going to give me 8x, and I'm going to want to get rid of this plus 10. So I'm going to do that in the exact same step. That way my 10 cancels on the left side, leaving me with 8x. And on the right side, my 2x's cancel, leaving me with 24. Now I can cross off both of those steps there. I did both of those. I also did my top one. And I can just isolate x now by dividing by 8. All right, so I like to do that to save myself some time in writing. If you want to do that, that's fine. If you'd rather do it 2 steps, like we did here, where I moved my x first and then my constant, that's okay. All right, if you're comfortable doing both at the exact same time, great. All right, let's check it. Always go back to the original, not the simplified version of it. Notice I'm going back to the original equation. I'm going to plug that in. Minus 34 minus 2 times 3. And you can take your calculator. You can plug it into both sides. If you do, you'll find out that you get 28 on the left side, 28 on the right side. It works out because, once again, 3 in this case is the value of the variable that makes this equation true. That's why it's the solution. All right, let's take a look at this one right here, number 6. All right, now all of a sudden it's a little bit bigger. All right, we've got some combining like terms to do, but I notice I have parentheses. So first thing I'm going to do is distribute. Get rid of those parentheses. I'm going to distribute that 5, giving me 10x minus 15. The minus 2x doesn't change. My equal sign is going to stay right there, and I can't do anything with 9 plus 2x. The second part of simplifying is to combine my like terms. You're going to do this on each side separately, all right? Just to simplify that side. You're not really doing anything to the equation except reducing the way it looks. So 10x and negative 2x, I can combine these two right here. All right, that gives me an 8x altogether minus 15 equals 9 plus 2x. Now I'm going to work toward moving all my x's to one side and getting all my other terms to the other side. I'm going to choose to move the 2x, so I will subtract 2x. That means my x's will be on the left, so I'm also going to want to get rid of this 15. I'll do the opposite by adding 15. This gives me 6x, as these will cancel. My 2x's cancel over here, giving me an equal to 24. And that's steps 2 and 3 in this case. Now I isolate x. Again, it's 6 times x, so I do the opposite division. Divide by 6 on both sides, finding that x equals 4. Now, is that the true answer? Well, let's double check it. Again, you can always plug it back in. I'll substitute. In this case, it'll go in for x right here. All right, minus 2 times, that's an ugly 4. Let me fix that one for you. Whoop. All right, equals, and on the other side, I've got 9 plus, a little bit simpler on that other side there. All right, and if I do this and you boil it all down your calculator, you'll find that 17 does indeed equal 17. All right, and that's because that 4 is the solution here. 4 is the value of the variable that makes this equation true. If you haven't caught on to a pattern yet, you will. All right, let's take a look at our last example here. Last example, try this one out. Pause the video if you've been watching. You haven't tried any of these on your own. Pause it. See how you do. All right, I'm assuming that you paused it. You already figured out the problem. Now you're coming back into it. Let's see if you got caught by one of our first traps here. One of the traps that they try to get you with is the 4 minus 8. A lot of people tend to do that first. It's a mistake. Again, follow our steps. Simplify both sides by distributing and combining like terms. I'm going to distribute that negative 8 first. The 4 is not touched, but negative 8 times 3 is a negative 24x. Negative 8 times negative 5 is a positive 40. A lot of mistakes are typically made by making that a negative by accident. Now I'm going to combine my like terms. On the left side, I notice I have 40 and 4. Don't lose the negative 24. It's still a negative 24x, but 40 and 4 is 44, and it's a positive 44 equals to 92. Now, done step number 1. All my x's are already on the left side, so I'm just going to move any term that's not an x. So I'm going to subtract 44 from each side. In this case here, I get negative 24x equals 48. And then I'm going to divide by that negative 24 to isolate x. That would be my final step here. Again, I'm doing the opposite of multiplication. I'm doing division. Make sure you're dividing by a negative 24 in this case. X equals negative 2. All right, and we can plug that back into the original. 4 minus 8, parentheses, 3, comma, negative 2. Careful with that. Minus 5 and parentheses. On the other side, does it equal 92? Well, if you plug the left side into the calculator, you will find that you get 92 equals 92. Because once again, if negative 2 is the solution, and this is the main thing to bring home today, all right, along with the steps on how to solve it, but a solution to an equation is the value of the variable that makes the equation true. Negative 2 is the value of x that makes this equation true. With that, you should be able to check every single answer to any equation ever before turning in any test, before turning in any work, whatever it is. You should know if you got the equation right because you can always test it. It is the value of the variable that makes the equation true.